So let's take a look on the example 20. That is an inequality. Okay, we have to prove a mathematical induction to prove this identity is true for all positive integers n. So it's as same as others mi. Just we have to prove it starting from n equals to 1. So look at what will it looks like when n equals to 1. When n equals to 1, that actually is 1, right? 1 over square root r with a summation sign in front of that, r plus 1 to r to 1. That is actually 1. Okay, so the left hand side is 1. So how about the right hand side? The right hand side, you can look put 1 inside, that is 2 times square root 2 minus 1, and use your calculator. You can get the result, that is 0.828, which is obviously that left hand side is larger than right hand side. So P1 is true. P1 is true. Oh, I forgot. You have to write the proof. Let Pn be the statement first. Let Pn be the statement, that is a summation r from 1 to n, 1 over square root r larger than the bracket 2 times square root n plus 1 minus 1. That is our assumption, the proposition, okay, for positive integers n. Okay, so the n plus 1 part is done, so we can assume the pk is true. So I have rearranged the page outline, and this one is our assumption. And now we have to prove for n equals to k plus 1. I will write it in the right hand side because there are more space here. So for n equals to k plus 1. However, we won't calculate the left hand side and right hand side just like when n equals to 1. Instead, we will calculate this one. Okay, when we will calculate r equals to 1 k plus 1, 1 over square root r minus 2 bracket square root k plus 2 minus 1. Okay, why we will calculate this one? Because when we compare two number size, just like 3 and 1, it is obvious that 3 is larger than 1, but sometimes we can prove another statement, just like 3 minus 1 is larger than 0. This one is much easier because when you are in an inequality, that is 3 of course is larger than 1, but sometimes when it is more complicated, when you calculate the difference of them, it's actually easier because you know that 3 is larger than 2 and 2 is larger than 1, because the inequality won't restrict on the specific number. We can just compare the size of them. So if you didn't use the difference of them, it is quite hard to convert this part into the next part of the inequality. So it is the main difference, and why the inequality in MI is much harder than the normal divisibility or just proof of some identity for in MI. So we have skills that we have to calculate, okay, the difference of the left hand side of right hand side. Instead, we have to convert the left hand side to the right hand side. Okay, there's the tricks and quite interesting part in MI for inequality. So now the starting point is here. We have to calculate the difference of left hand side and right hand side. So for the first part, we as same as previous MI, we have to separate the term first. That is equal sign, that is k summation r equals to 1 over square root r minus we have to add the remaining part first, that is square root k plus 1. Okay, and then minus 2 square root k plus 2 minus 1. Because then now we can use the pk statement and pk's assumption, that is for this part it actually is larger than this one. So what you have to do is from equal sign, it turns to the larger sign because this one is larger than this one. So when it converts, when using the part A, that is already larger than 2 square root k plus 1 minus 1 plus 1 over square root k plus 1 minus 2 brackets k plus 2 minus 1. Oh, there are no enough space, so I will rearrange the terms again. As the n equals to 1 is trivial, so I just remove it and focus on the n equals to k plus 1 part. And now it's already the inequality side, and we have to simplify these few terms. Okay, let me remove the bracket first. That is equals to, because from this part to this part, we use the results of assumptions that we will draw a star here. Okay, and then I will write it from star. Now, so but from this step to next step, it actually just simplifies. So we'll use the equal sign again. That is 2 square root k plus 1 minus 2 plus 1 over square root k plus 1 minus 2 square root k plus 2 and then plus 2. That's 2 can be eliminated. And then what we do next is just take out the common factor k plus 1. Okay, we take out the common the factor, the denominator, square root k plus 1, just like what we did before. That is 2k plus 2. Okay, because that is we take out the square root k plus 1, that is k plus 1 square root and then square, that actually is k plus 1, and multiply by 2, that is 2k plus 2, and then this one become 1, and then for the next part, that is 2 square root k plus 2 times square root k plus 1. Okay, that's the situation now. But what will we go next to prove that? So for this statement, okay, we have to prove that the left hand side is larger than right hand side. However, for this part, this statement, we actually only need to prove it is larger than 0. Okay, it is larger than 0. But how can we prove that it is larger than 0? So let's take a look on this term. If you get familiar with the identity of perfect square, actually you can see the pattern. Okay, there is a 2 here and 2 square root, 2 factors of square root here. So actually we can do the completing square. Oh, no space again. I will reduce the size first. So if you don't know what does it mean, just write it down and you will know why. That is k plus 1 square root square. Okay, and then for the minus 2k plus 2 times k plus 1, and then plus square root k plus 2 square. Right? Take a look at these two terms. Did this actually equals to k plus 1, and this actually equals to k plus 2, and the sum of these two terms actually is 2k plus 2 plus 1, that is 2k plus 3. Okay, so these two terms actually from these terms. Okay, and then these two you can see that is the pattern of a squared plus 2ab minus 2ab plus b squared. That actually equals to a minus b squared. So this becomes square root k plus 1. Okay, and then square root k plus 1 minus square root k plus 2 square. So now can you tell me that this term is larger than 0 or not? Of course it is larger than 0, or the minimum value of this term actually is 0. So what will it goes to minimum? Of course, when k is a number, okay, just like I'm talking something useless. K is of course a number. For assume pk is true, that k is some positive number. And these two terms, actually this one is larger than this one. But we have a whole square here. That means this one must be a positive number. And then times the 1 over square root k plus 1 is still a positive number. That means it is larger than 0. Okay, when we get that this is larger than 0, what does it mean? Okay, for this statement is larger than 0. That means equals to 1, from r equals to 1 to k plus 1, 1 over square root r is larger than 2 square root k plus 2 minus 1 here. Okay, so the pk plus 1 is true. Okay, so why the inequality in MI is hard? Because you have to know this step by step. You have to first think about we can't easily find the left hand side larger than right hand side, so we will use the difference of the left hand side and right hand side, and you have to think how to convert this term larger than 0. And some of the skills are using the completing square, okay, using the perfect square of two terms, and it is quite hard to think if you didn't practice well. So I just talk with you through the videos, and please take a look and have an impression. That's just for extra information. You won't have faced the examination of this kind of questions. So just know how to do it. Oh, of course, for the last statement, you have to write, by the principle of MI, and then Pn is true for all positive integers n. Okay, so just ask me if you have any problems on this question, and we still have one questions left, but that is HKCEE AMAth 1980 1980s questions. You have to learn about the quadratic equation first, but you haven't learned it, so I will give the answers to you later after you in your core part you have learned the quadratic equation first. That's the end of today's video. Please hope you enjoy this.